Welcome back, everybody. So we're just going to finish up this lesson by, so now that we know what polar coordinates are, and we want to see how we can convert equations from equations in r and theta to x and y and vice versa. Okay, so and we're also going to see how these polar equations can describe certain graphs, and we're going to do a lot more of this graphing stuff in the next section. But let's suppose you have the equation r equals 6. Okay, now this is actually, if you think about this, this is just there's no theta here. So if you don't see theta, you assume theta can be anything. So if you just really this really is meant to describe all points where r is 6. Okay, and if you think about, since r is the distance from the origin, we're just thinking of all points who's exactly 6 units from the origin, so it's a circle of radius 6. Okay, so but if we weren't sure about that, we could just say, okay, r squared is 36, and r squared is x squared plus y squared equal. So this would be x squared plus y squared equals 6 squared. So this is a circle of radius 6 centered at the origin. So it's a circle. Okay, and in general, if r equals a constant, that's always going to be a circle centered at the origin. Okay, what about number 11 here? R cosine theta. Remember, r cosine theta, by the formula said this is just equal to x. So x equals 2, and this is just the vertical line of 2. Okay, that was easy enough. Okay, and similarly, you could see that r sine theta equals 5 would be the line y equals 5. Okay. All right, what about this one, number 12, r equals 2 cosine theta? Now, we want to resist the temptation to start plugging in values. You could think, okay, since r is kind of like the dependent variable, and theta is the independent variable, so you could like plug in various angles for theta and see what the r's will be. But probably an easier way to do this is just to use the relationship to write this in terms of x and y. Now, how do you do that? Well, here this is a little tough because there's no r here, but there's no reason why you can't multiply both sides by r, and then you'll get an r over here. So if you multiply both sides by r, you get r squared, and this is 2r cosine theta. Now I group the r next to the cosine theta because we know that this is x. And so r squared, of course, is x squared plus y squared. So we get x squared plus y squared equals 2x. Okay, so now everything is in terms of x and y. And this, theoretically, is something we know how to do by completing the square. If you go back to that section on conics, we can subtract 2x from both sides. Okay. And then complete the square. In this case, it's not too bad. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we add 1 to both sides. This is x minus 1 squared. This is y squared plus 1. We can keep the 1 here and subtract y squared. Okay, and guess what? This is a circle. Okay, it's a circle of radius 1 that's centered at 1, 0. So actually it's going to look like this. Okay, because this is the same thing as, x minus 1 squared plus y minus 0 squared equals 1 squared. Okay, so it's a circle. And similarly, you can do the same thing for this. You can multiply r equals 3 sine theta. You can multiply both sides by r. We'll get r squared equals 3r sine theta. Okay, and we do this because this is y. So we'll get x squared plus y squared equals 3y. We can subtract 3y from both sides. Okay, now we will, and then we can complete the square for the y's. So you have negative 3 divided by 2 is 3, negative 3 halves. Negative 3 halves you square, you get 9/4. So you get, okay, and so you get x squared plus y minus 3 halves squared equals 9/4. Okay, so this is a circle now. This is a circle. It's a different circle. It's not. It's the center is going to be 0, comma 1 3 halves, and the radius will be 3 halves. So it actually will look like this. Okay, so that's what this circle would look like. Just by completing the square and knowing how the equations of circles. Okay, if theta equals pi over 6, whenever theta equals a constant, that means there's no mention of r, so r can be anything. So pi over, we're looking at all the angles whose theta coordinate would be pi over 6 or 30 degrees. Okay, well that would definitely include this line right here. Okay, so everything, that would include everything on this line, but it will also include everything on this line extended that way, because this would be the negative values of r. Okay. Okay, so this is just going to be a line. So this will be a line through the origin, and the slope will be whatever that will be the tangent of pi over 6. Okay, and then so in that case, you know, I guess you could write this. The actual equation would be y equals the tangent of pi over 6 times x. So this would be y equals 1 over square root 3 times x. Okay. Then, well, finally, x squared equals y, or y equals x squared. We know that's a parabola, but what would this be in terms of x and y? Well, we just have to in terms of r and theta, all we have to do is replace x with r cosine theta and y with r sine theta. And then we're practically done. This would be r squared cosine squared theta equals r sine theta. And divide both sides by r. And so all we get r cosine squared theta equals sine theta. Okay, so you could maybe leave it like this, or you could say r cosine squared theta minus sine theta equals 0. Or I guess you could even write this, you know, play around with this and get r equals secant theta, tangent theta. If you want to play around with trig functions, that's okay. But either this answer or this answer would be fine. Okay. And that is all we have right now. So we're going to be doing a lot more with graphs in the next lesson. So get lots of practice, and I'll see you next time.